All right, this is lesson 2.10 in pre-algebra, solving one-step equations by multiplying or dividing. So, okay, here's the deal. Let's do a quick little review of the adding and subtracting. Let's go a plus 5 is less than or equal to 7. What do I do here? Line down the inequality. C is a variable happy. No, this is just like a regular equation, right? Except it's an inequality. Go minus 5. They're gone. A is less than or equal to 2, right? Yep. Okay. And then you graph that by putting down 0 always. And then you put down the number that we're talking about, 2. And then this says less than or equal to. Which way is less than? Left. To the left. And so you less than or equal to. Or equal to means it's a solid dot. If this was just A is less than 2, what would that look like? Open dot. It would be an open dot to the left. Does that make sense? Okay. That's how you do addition and subtraction. The only kind of weird thing about addition and subtraction is if it ends up being, 5 is less than X, read that to me. That is X is greater than 5. You read it from what? The variable's point of view. So when you graph it, you have to graph it from the variable's point of view, right? Right? Yes. Okay. Now, so here's the deal. I'm going to give you a regular old equation here. What if I have this? 2x equals 10. What do I do here with this equation? Line down the equal sign. Then you look and see, is the variable happy? Is he happy? No, he's not alone. Who's with him? The 2. What's the 2 doing to him? Multiplying. What's the opposite of multiply by 2? Divide by 2, divide by 2. Whatever you do to one side, you have to do the exact same thing to the other, right? Those 2's are gone. Why are those 2 gone? Because 2 over 2 is 1. 2 over 2 is 1, right? And 1 times x is 1. 1 times x is x. That's why we get to get rid of them. X equals 10 divided by 2 is 5, right? Simple stuff. If I was to ask you to graph this, how could you graph this? X equals 5. You have to be able to graph this. X equals 5 is you would go like this. There's 0, there's 5, and you would put a solid dot. I mean, you could put it right there if you wanted, but whatever. It goes right here. That's x equals 5. There's no greater than or less than, but that's how you'd graph x equals 5. Does that make sense? That's what you do. Okay, but I don't ever have you graph that because it's not important yet. But here's the deal. So, okay, we had that. We had this. You know how to do that. Let's do an easier one. Let's go like this. 2x is greater than 10. Okay, so here's the difference. You ready? This is tough. Line down the inequality. Is the variable happy? No. Divide by 2. Divide by 2. X is greater than 5. I mean, is that any more difficult? Not at all. You do need to remember to put the inequality on the line, not an equal sign, right? Because it's not an equal sign, it's an inequality. And how would you graph x is greater than 5? It's simple. 0, 5. Open circle to the right. Why open? Because it's just, is 5 a part of the solution? No. It's everything up to 5. What about 5.000000001? Nope. Yes. 5.0000001 is greater than 5. Right? But not 5. Right? Okay. Okay, what about this then? What if I have negative 14 is less than 7m? Here's what we do. Line down the inequality. Divide this by 7. Divide this by 7. M is greater than negative 2. Does that make sense? I mean, nothing changes here. You'd graph this. 0, negative 2. M is greater than that. Right? Makes sense? This is nothing. Yes, Sheena. Not Sheena. Yes, Kyla.
Since you do negative 2, it says everything up to it, but not exactly. Why wouldn't you just go 1 ahead?
Give me the number you're talking about.
So basically on this, why wouldn't you put negative 1?
Because what is negative 1.5? Isn't that still bigger than 2?
Yeah.
Bigger than negative 2? Does that make sense? I mean, and no matter what number you choose, I can always make one smaller or bigger. Right? Always. Just decimals. Now, here's the deal. Here's the only tricky part about, well, let me show you a division one. What about this? What if I have m over 4 equals 16? Here we go. Line down the equal sign. Multiply by 4. Multiply by 4. Right? We've done this before. M equals 64. We've done that. Right? That should be nothing new to anyone. Okay, what about this then? M over 4 is less than or equal to 16. Line down the inequality, times 4 times 4, m less than or equal to 64. Nothing changes. It's the exact same thing. Okay? You have to be meticulous. What's meticulous mean? Careful. Very, like really meticulous means you're being very careful. You're thoughtful. You've got to be meticulous about this, because what sometimes happens to some people is they go m over 4 is greater than or equal to 16, and then they go times 4 times 4, and then they go m equals 64. And that's wrong. Right? That's not meticulous. And a lot of times, here's what causes problems, is if I have this, 16 is greater than or equal to m over 4, and you go like this, and then you go times 4 times 4, and you go 64 equals m, and then you go, oh, okay, then you look up here at the sign, and you go, oh, so m is greater than, so you go, okay, here's how you'd graph it, because you're not graphing it from the, you get confused. You see what I'm saying? Like you didn't, right? Can't do that. Got to be meticulous. Now, here's the tricky part. Okay, there's only one thing. I could give you this assignment right now if it wasn't for this one little thing, and it's so simple. You just have to remember to do it. Again, you have to be meticulous. Here it is. Negative 3x equals 12. Here's the rule. Let's do this one. This is an equation. Line on the equal sign, divided by negative 3, divided by negative 3. X equals, what's 12 divided by negative 3? A positive divided by negative 4. We're done, right? That would be the equation. Let's do the exact same thing. Negative 3x is greater than 12. Line down the inequality. Divided by negative 3, divided by negative 3. Here's the rule. You ready for the rule? Anytime you are going to multiply or divide both sides of an inequality by a negative, whenever you multiply both sides of an inequality by a negative, you have to flip the sign. The sign gets flipped. So this would be this. This is now x is less than negative 4. That's just the rule. Anytime you multiply or divide both sides of an inequality by a negative, you have to flip the sign. That's the only weird thing. You just have to remember to do it. Okay? You should write that down somewhere in words. Whenever you multiply or divide both sides of an inequality by a negative, you have to flip the sign. We've done those before. Do we flip signs? What do you mean flip the sign? Yeah, flip it. What would flipping an equal sign be? Oh.
So it would be whenever you multiply or divide by an inequality.
And whenever you multiply or divide both sides of an inequality by a negative, you have to flip the sign. Okay, so you're watching this again. This one is one that's a little bit different. This is a division one. So what do I do here? What's the first thing I do? Line down the inequality. Next thing you do is you look and see if the variable happy. Is he happy? No. He's being divided by negative 3. How do I get rid of divided by negative 3? Multiply by negative 3, multiply by negative 3. I just multiplied both sides by a negative. That means this sign gets flipped over. Nothing else changes. Y is greater than a positive 24. Why positive 24? Negative times a negative is a positive, and we're done. I could ask you to graph this. I believe that they do sometimes. You have to learn how to graph this, right? You shouldn't have to learn how to graph it. You should know how to graph it. Okay, here's a tricky thing. Okay, and this is where you don't get confused by this. What if I give you this? X plus 4 is greater than or equal to negative 6. Paying attention. Line down the inequality. Is he happy? No. What do I need to do? Minus 4 minus 4. If you're not paying attention, what will you think you might have just done? I just subtracted 4 from both sides. Do I flip the sign when I subtract both sides? No. It's only when you multiply or divide by a negative. Got to remember that. Okay, the signs here don't flip. X is greater than or equal to -10. Okay? Okay, let's take a small quiz right now because this is just going to be what you guys do. I mean, I'm going to choose some odd ones right here, right now. That's on your homework. Let's see how you do. We'll choose...
Do you have to graph it?
No. Okay, do those 4. All right, so here we go. You're watching. This is where you learn. First thing, number 1, line down the inequality. You look, is the variable happy? No, he's not alone, right? He's got to be alone. He's a hermit. How are we going to get him alone? There's a -4 with him. What's the -4 doing? Multiplying him. So how do I get rid of multiply by -4? Divide by -4, divide by -4. Now, that I just divided by -4. What do I need to do right away? Don't forget this. If you don't do it now, you'll forget. You flip the sign. Flip the sign. Those -4s are gone. That leaves me with x is greater than -2. Does that make sense? X is greater than -2. Can you write it like this? X is greater than -2. Could you write it like that? Absolutely. Right? But you read it from the variable's point of view. Okay? Number 2. Line down the inequality. Is the variable happy? No, he's being... See, sometimes this gets people confused. He's being multiplied by 5. No. Number 2. He's being multiplied by 5. What's the opposite of multiply by 5? Divide by 5, divide by 5. Now, some people get a little confused because this is going to end up being negative. Do I flip the sign here?
No.
No, I did not multiply or divide by a negative. I multiplied and divided by a positive, which means nothing. They're gone. F is greater than or equal to -3. How many of you got that? Did you get that one?
I flipped the sign.
I see that happens sometimes. I'm telling you, it happens. So what's the rule? When do you flip the sign?
When you're dividing by it?
When you multiply or divide by a negative. Listen, I didn't multiply by a negative. I multiplied by 5, right? That's a positive. Even though the answer over here ended up being a negative, that's not the point. What I did with my sides, what I did with my balance here, is I took what I had here and I multiplied it by 5. And I took what I had here and I multiplied it by 5. I didn't multiply it by a -5. I multiplied it by 5. And so that's where you've got to know the difference. Okay, we're going to do number 4 now really quick. We'll come back to 3 in a second. Number 4, line down the inequality. Is the variable happy? No, he's being divided by -6. What's the opposite? Divide by -6? Multiply by a -6. Multiply by a -6. I just multiplied by a negative right now. Flip that sign. Right? They're gone. M is greater than -18. Make sense? Make sense? Okay. Now, number 3. Here's the deal. Line down the inequality. Nothing changes. Line down the inequality. Is the variable happy? The answer is no. He's not alone. There's a minus in front of him, right? Here's the thing. He's a negative, right? He hates being a negative. I mean, like, that is the worst. But really, all that it is listen. If I have the variable m, what's another way of writing m?
1.
It's a 1m, right? We just don't write the 1 because that's what's called redundant, right? That's redundant. I don't need to put a 1 there. If there's just an m, we already know there's just 1. You don't put a 1m. Just like if there's an x there, there's really a 1 there. We don't write it, but it's there. It's -1x. So then, if I want to, what can I do here? He's being multiplied by -1. What's the opposite of multiply by -1? Divide by -1. Divide by -1. I just divided by a negative, which means that I have to flip the sign. x is now less than negative 21. I want to show you the shortcut to this. Okay, I'm going to show you the shortcut to this. Here's the deal. If you ever get it like this, where the variable is a negative, notice what happens here. When I multiply him by negative 1, you see what actually happened to it? It ended up being x is less than negative 21. Every sign that's there simply gets flipped. Everything gets flipped over. This x, the negative x, becomes an x. This sign gets flipped over to here, and the 21 becomes a negative 21. So whenever you're going to whenever you have a negative variable and you're like, yuck, right then and there, you can flip every sign. Even if it looks like this. I mean, like this is a little more complicated, but if it ended up looking like this, 5 minus m is less than negative 30. What I'm allowed to do, what do I notice right off the bat? That variable is negative. That's no good. You know that's not going to end up being good. I'm going to end up going minus 5, and do all this, right? But I don't even need to. Right now, if I wanted to, I can flip every single thing on here and make it go negative 5 plus m is greater than 30. Notice I flipped that to a negative, I flipped that to a positive, I flipped that to a greater than, and I flipped that to a positive. Everything gets flipped. Totally legal. Totally legal. In fact, you can do that anytime you want to for any reason whatsoever. I could give you a, 2x to the 4th minus 5y plus 7 is greater than or even it equals, whatever, is greater than or equal to negative 64. And if I want to, I can go negative 2x to the 4th plus 5y minus 7 is less than or equal to 64. I just multiplied everything by negative 1. I flipped everything. I'm allowed to do that. I'm not saying you're ever going to want to. I'm saying you're allowed to. Does that make sense? So if you ever see this, if you ever come down to it, here it comes. It's negative m. It equals, negative 4. What do? You flip. No, don't say 1. What do? You don't. Can the variable be negative? Is he happy? Are we done? No, he hates that. So what do I do? Multiply everything by negative 1. What does that in essence do when I multiply everything by negative 1? Listen, what is negative 40 times negative 1? 40. What is negative 412 times negative 1? 412. What is positive, or what is 7 times negative 1? Negative 7. It just opposites, right? It just becomes opposite. So what can I do with this if I want to? I don't even need to go times negative 1 times negative 1. I don't need to do that. What can I do here? Flip everything. That negative m becomes m. That equal sign, you flip an equal sign, it's still an equal sign. And the negative 4 becomes a 4. That's all you have to do. If you want to do it the long ways, you can. Negative m equals negative 4. You go, okay, times negative 1 times negative 1. This becomes an m, and this becomes a 4. You can do that. It's just not necessary, right? I mean, that's a shortcut you should be able to do. Anytime you want to, you can flip every sign in an equation or an inequality. The problem is that if you're going to flip every sign in an inequality, you also have to remember to flip the inequality. You have to flip the sign itself. Make sense? That's just the tricky thing to it. That's it. I think you guys can do this. This is not a super complicated assignment. You just have to remember to, when you multiply or divide both sides by a negative, you flip the sign. One thing that you're going to have to learn too is this. I'm going to show you one that's more complicated than you have right now. But if I gave you this, make it an even one, make it greater than 6. Here's the deal. Line down the inequality. Do you recognize this yet? What do I do with that? Distributive property, right? And so what am I doing here? I'm distributing what am I distributing in the parentheses? No, what am I distributing? I'm distributing the negative 2. Negative 2 times x and negative 2 times 1. I'm multiplying by negative 2. Does that mean that I flip the sign? Why not? Why don't I flip the sign here, people?
Because you're not multiplying on both sides.
I'm not multiplying and dividing both sides by a negative. I'm simply multiplying this side. I'm really only distributing the negative 2. You wouldn't even say I'm multiplying it by negative 2. I would say that, wow. I would say that I am distributing the negative 2. This would be negative 2x minus 2 is greater than 6, and then we would go from here. But we did not need to flip the sign because I did not multiply both sides by a negative. Okay, let me give you your homework. Do you want to watch the, do you want to look at the, where is it? Oh, right. So page 113, 1 through 12 even, that's it? No, 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 that can't be true. Yeah, no way, that's a lie. I got to fix that. Page 1 through 13, oh, we're going to go 1 through 37 even. Much better. Good Lord.
That's still not that much.
It's not. It's really not. Thank you, Jade. That's right.